Hello everyone, myself Archana Priya. Today our topic is current electricity. Electricity, it's a very interesting topic and you feel so much curiosity will be there by learning this chapter. So why? Because in our daily life there is so many electrical appliances. You start thinking that how it actually working, and you have that curiosity to know about that. So you will get so many answers in this chapter, how exactly it is working and what are the characteristics of the electricity and the electric current. You will come to know in this chapter. And see, electric current, here you will learn what exactly the electric current is and characteristics of the electric current. Next, drift velocity. Drift velocity, how does the drift velocity is occurred? On which basis it has occurred? You have few problems in that, so you need to solve it, which will be useful for your JEE exams or NEET exams. Next, you have about the Ohm's law. You will know what exactly the Ohm's law. Ohm's law, which shows the relationship between voltage and current. Based on this voltage and current, you can derive the resistance. So you will study about the electrical resistance and how the electrical resistance will be depending on which factor it will be depending. Based on that, you will be having few problems again. And we will be studying about the electrical resistivity. Each material will be having its own resistivity, on which you are considering the resistivity and on which conditions it will be applied. Next, how does the current will be resisted on that particular material. Like this we will be studying about the electrical resistivity, and even while studying the resistivity you can know what is the relationship between the conductivity. So how much the conductor will allows the current, and resistivity is how much the conductor or the material will be resisting the current. So these relations also will come to know that. Next, about the VI characteristics. VI characteristics, even I can say as a Ohm's law characteristics. Already I said you Ohm's law is nothing but you can know the relationship between the voltage and the current. So you will know what is the characteristics of the Ohm's law. Now, Ohm's law is not applicable in all the conditions. Few conditions it fails to explain. That is called as non-ohmic conductors, where you will study the non-ohmic conductors too. Then, color code resistance. Here you will be having a color code for every resistance, and you should calculate, and you will come to know how to calculate the resistance. Next, to our main topic, let us come to study here electric current. See, before starting the electric current, we know that all the substance is made up of atom. And atom is made up of proton, neutron, electron. These are the fundamental units. Where charge is nothing but a unit of a matter. Where you can see this proton and electron is nothing but a charged particles which is having a positive charge. Electron is having a negative charge. Positron is having the positive charge. Where neutron, which is having a no charge. So now we will define the current. How we will define the current? So you have first, before going to a definition, we should know exactly what are the characteristics of the charges. See, charge where the SI it is defined by the, or its symbol is by the Q, and its SI unit is nothing but coulomb. So the charge will be flowing in the conductors when the rate of flow of charge is taken place. Then I can say it as current. A rate of flow of charge, I can say it as current. You have two conditions. Current when it is, or the rate of flow is taking place in a steady. So the rate of change of current is steady, means just a formula I is equals to Q by T, where Q is equals to N into E, N into E, where N is the number of charges, that is nothing but electron, or I can say the flow of electrons too. Now we have one more thing. When the charge is not flowing steadily, means if there is any variation, that is called as instantaneous current. So we have two types to define the current. One, there is a steady flow. Most of the devices will be working on the steady flow itself. If there is any variations, so that is not steady. We will be having an instantaneous current. For that we have a formula, I is equals to delta Q by delta T. For steady current we have I is equals to Q by T, that is nothing but N into E. Q is N into E by T. Now we will discuss about the units of the current. So the SI unit of the current is ampere, and we have a small unit too, that is we can measure the current in the small unit, that is nothing but microampere. Micro value is 10 to the power of minus 6. So you have 10 to the power of minus 6 ampere. Next, milliampere, 10 to the power of minus 3 ampere. This is the smallest unit to measure the current. Next, about the dimension formula. So the current has a dimension formula where you are representing with the square brackets. A is the dimension formula, or even you can measure it, or even you can write it as I. This is about the dimension formula. When you can say it has a 1 ampere, when you can say the current is flowing in a 1 ampere, when 1 coulomb of charge is flowing in a cross-sectional area in 1 unit of time, then you can say it as a 1 ampere. 1 coulomb of charge is flowing in a cross-sectional area in 1 second, then we can say it as a 1 ampere. Next you have, if I want to convert from SI unit to CGS unit, 1 by 10 electromagnetic unit. So the charge, see, 1 ampere we will be defining with the SI unit. Ampere is a SI unit. Now I want in terms of CGS unit. So I have written this. So 1 by 10 of electromagnetic unit. So by second. So 1 by 10 by watt. So even it is called as CGS unit is nothing but a biot. Now we have one more thing which you cannot mention, that is ESU. ESU means electrostatic unit. So this will be equals to 3 into 10 to the power of 9. Of 3 into 10 to the power of 9. Now the current is the same in all cross-sectional area. If you consider a cross-sectional area, when the current is flowing, it will be flowing same in all the direction in the cross-sectional area, all across the cross-sectional area. Suppose the cross-sectional area is small, then the current will flow very fastly. Suppose the cross-sectional area having a large cross-sectional area, then it is current will be flowing very slowly. Next, we have about the direction of current. Direction of current, see, the direction of current is always opposite to the electrons. It is always opposite to your electrons. Where coming for, the current will be flowing in the direction of positron. How the positive charges will be moving, in the same direction your current will be moving. This is about the direction. But when you are discussing about the direction of current, you feel that current is a vector quantity. No, current is not your vector quantity, because whatever the direction it is showing, it's a false direction. It will not obey your parallelogram law, vector's parallelogram law. So usually we will say the current is a scalar or a tensor quantity. Here you can see in a diagram, the I1 is flowing here, I2 is flowing here, it reaches one particular point. Finally it will be I is equals to I1 plus I2. The two current from different direction, you think. So this is from here, and your two wires will be connected and reach at one particular point. There your final current will be I1 plus I2. If I take an example, 5, 3, your final current will be 5 plus 3, that is nothing but 8. And one more thing, whatever the theta is, this will be your product. Whatever the theta, it is maybe 90, 100 or 120, whatever, I will be equals to I1 plus I2. Next, charge is conserved. The charge will be conserved at all the situation. So what will be the charge in the cross-sectional area at one end, same will be the other cross-sectional area. If I take an example, if I connected a conductor to a battery If I connect the conductor to the battery, see, battery is a source of energy, so it will give the energy to the charges which is there in the conductor. So the charges will gain the energy and it will go with a large kinetic energy, or I can say when it gains the energy, the velocity increases, even kinetic energy increases. So only the increasing of kinetic energy or the energy is gaining the energy, that's it. So there is no changes or there is no variation in the charge will be same, therefore your charge is conserved. Current is different in situations, obviously. See, as we are human beings, we will be different in different situation. Example, in house we will be in a different manner, maybe in silent or rough or rude, whatever. So if you go for classes, again there you will be having a different behavior. With your friends, again there is a different behavior. Same like that, a current will be having a different behavior, so it behaves differently. Conductors, motion of electrons will be taken place. Where coming for electrolytes, there will be motion of positive and negative ions. Next, semiconductors, motion of electrons and holes. See, there is a different situations the current will be varying. Next, you have two types of electric current. One is direct current, one is alternate current. Where coming for direct current, it is a unidirectional. It is not going to change its direction. You can see the graph over here, velocity versus time. So you can see the straight line which is parallel to your time axis. There is no direction is changing. It's just a unidirectional. Magnitude also will remain same. We're coming for alternate current. Here it will flips the direction. It will be flipping its direction. See, from here you can see here to here it completes one cycle. In the off of the cycle, one is positive, one is negative. But you should keep in mind your amplitude will be same. So this is about your different types of electric current. So next you have a problems based on your electric current.